Thank you. Okay, now when you have a question like this, what is the first thing we need to do? So, okay, so this is a review session. I really would like you to participate a little bit, to answer, suggest what you think are the right ways of solving this. So we have a line integral ds. So we're integrating along this curve C, which is basically a straight line from this point -1, 2, 1 to this point 0, 4, 4. So this is the curve C. Now, what do we do in these kind of questions? Do you remember? Yep, thanks, Noor, yes. We need to find the parametric equations. We need to find the parametric equations of the curve C. So always, first step, parametric equations. Yeah. The parametric equations are, this is a line segment. You may remember we did a lot of 2 or 3 examples like this. So what is the parametric equation for this line segment? You remember what we did? So we take, yeah, -1, yeah, plus 0 minus -1. So it's 1t, that's x, thank you. Yeah. So it's -1 plus t. The y will be 2, good, 2 plus 2t, that's fine, good. And the z will be 1 plus 3t, great. And t from, this is important, t from where to where? From 0 to 1, always, huh? 0 to 1. Great, so these are the parametric equations. We are also going to need x prime. What is the derivative of x with respect to t? 1, yeah. We also need to find y dash, which is t, yeah. And we need to find z dash, which is 3. Okay, great. So now we can write, so the integral of 3x minus 2y ds will be the integral from 0 to 1, 3 times x, yeah, so we substitute, -1 plus t, minus 2 times the y, which is 2 plus 2t, and then the ds, what is the ds? It's the big square root, yeah? It's the square root of 1 squared plus 2 squared plus 3 squared, like this, dt, yeah, and then we integrate this with respect to t. Is that okay, or? Sorry, I don't understand, Salha, what are you asking? We don't have z, yes, yeah, but still it has to be, yeah, the ds, remember ds, always, ds is always, we are working in 3 dimensions. Remember the points have x, y, z, x, y, z. So that means we are in 3 dimensions. Be careful, yeah? if the point, yeah, I understand your question. If the points only have two coordinates, then there is no z. Yes, you're right. But here we are working in 3 dimensions, so there will be, so x dash prime squared plus y dash squared plus z dash squared, yeah, like this. Okay, after that, it's really simple to complete. So it's going to be the integral from 0 to 1. Let's open up these brackets. Yeah. If we open the brackets like this, so we're going to get, I think it seems minus 7, and then 3t, this times this will give you 3t, this times this is minus 4t, so minus t, and then square root of 14, 1 plus 4, yeah, square root of 14 dt. And the square root of 14 is a constant. You can take it out of the integral, and then you will get the integral from 0 to 1 minus 7 minus t dt. So square root of 14 minus 7t minus t squared over 2 from 0 to 1, and you substitute, yeah, in the you substitute, and you will see a final answer of, yeah, what will be the final answer? Substitute, put 1 here, so it's going to be minus 7, yeah, so it's minus 15, yeah, square root of 14 over 2, all of this like this. Or you can, yeah, you can give the answer as a decimal. That's also fine. So you can get the answer like this. Are we okay with this question? Yeah. So again, let me repeat. You are going definitely to see a question like this in the final. So you really need to make sure you know how to do this. Any question before I move on from this? Did you understand the process here? Yeah. So first, you need to find the parametric equations. That's always the first step. If they are not given to you, you need to find them. And then you substitute into the integral the x substituted, the y substitute, and the ds, use the formula. If it is dx, also there is a formula for dx, and there is a formula for dy, etc. So you need to know how to do this. Can we move on to the next question? Yeah. Okay. Right. Second question then, which is question 12 in the exam. We have a vector field F. I want to find the divergence of F. Okay. So, and the curl of F, and then we decide whether F is conservative or not. So, A, I want to find the divergence of F. The divergence of F, you may remember the definition. It's df1 over dx plus df2 over dy plus d of f3 over dz. So this is what is called the divergence. So we need to differentiate. This is F1, this is F2, this is F3. So what is dF1 over dx? 2x y cubed. Okay, good. Thank you. Plus dF2 over dy is a 2yz. Good. Thanks, Noor. Yeah. 2y z is fine. And finally, df3 over dz is just x. So this is the divergence of this function. Fairly easy, no problems here. Okay, now the curl is a little bit more. For the curl, we need to, do you remember how we work out the curl of a function f? Do you remember the rule here? Okay. It's basically determinant. The curl of a function f is the following determinant: ijk d over dx, d over dy, and d over dz. And you put here f1, you put here f2, and you put here f3. It's like this. So that's the general definition of the curl of a function f. So in this example we have in front of us, so it's going to be I, j, k, d over dx, derivative with respect to y, derivative with respect to z, and then I put the f1, which is x squared y to the power of 3. The f2 is y squared z, and f3 is xz, like this. So, and then we do this. It's I, then this with this, minus this with this. So it's going to be 0, yeah, minus y squared. Thank you, Salah. Yes, like this. And then minus j. And with j, you need to take this with this, minus this one with this one. So it's going to be z, yeah, and then minus 0. Thank you. Yes. And finally, plus k. With k, it's this and this, this, this. So 0, yeah, it's going to be 0 minus 3, yeah, 3x squared y squared, yeah, 3x squared y squared. Okay, great. So if I want to write this as a vector, then it will be minus y squared, and then minus z as a second component, and then the third component minus 3x squared y squared. So this is the curl of our function. Now, part C, is this function f conservative or not? So is this function f conservative? Do you remember how we do that? How do we know if a vector field, not by integrating, no. How do we know if a vector field is conservative or not? Any idea? No. It's quite a simple answer, actually. Yeah. F is conservative if and only if and only if its curl is equal to 0. Yes. The curl should be equal to 0. If it's 0, then f is conservative. Now look at the curl. Is it the vector 0? Is it equal to 0 here? Is the curl of f 0? It's not, yeah? It's a big vector. It has a lot of components. It's not 0, 0, 0, yeah? 0, 0, 0, like this. So is this f conservative then or not? What is our answer? F is not conservative. How do we justify this answer? How do we justify it? We say because curl of f is not actually equal to the vector 0, and that's it. So f is not conservative because its curl is not equal to 0. Are we okay so far? Will you be able to do this if it comes in the exam? Yeah? Okay. Good. And it will come. Believe me, these questions, they will come. That's it. There is no calculus 2. We have some set questions. They always come in the exam. There is no way of not getting them. Okay. Now, something we did a long time ago. I hope it's still in your minds. We have three vectors, A, B, C. Find the area of the parallelogram formed by the vectors A and B. So the A, so we have a vector A here, a vector B. I want to find the area of the parallelogram. I want to find the area of this parallelogram. Now, do you remember what is the area? How do we find the area? Yeah. Yes, it is the cross product. Yeah, you need to find the cross product of the two vectors. And what do we do after that? This is not the answer. How do we get the area? The cross product is going to be a vector, yes? A cross B is going to be a vector. Yeah, you have to take the magnitude, yes. That is the rule. So I will remind you about the rules as we solve these questions. So that's basically the way you do this. So you need to find the cross product of AB, and then you take the magnitude of that cross product. That will give you exactly the area of this parallelogram. Yes? No, when you use integrals, Salah, when you have functions. If you have a function and you want the area like this, then the area will be the integral of the function from A to B. Yeah? Is this what you are asking? Yes. Don't confuse this. Huh? If you have two vectors like this, and you want the area of the parallelogram between them, then it's nothing to do with integrals. It's you can answer that by vectors, things we did in the chapters on vectors. If you have functions, graphs and things like that, you want to find the area, then it's something to do with integrals. So you need to use integration. Okay, so it's a different kind of question. Good, thank you for asking. So now we are going to find the cross product first, and then we will find the magnitude. So the cross product, you may remember, I, J, K. Then we put the vector A, which is 1, 2, 3, and the vector B, which is -1, 2, 2, like this. So we will find now this vector. So it's going to be I 2 times 2 minus 3 times 2. So it's going to give us -2. So can I put -2 there? Yeah? Okay. And then after that, we take a minus j, and then it's this times this, minus this times this. So it's 5, yeah, it's exactly 5. Yeah, good. Yeah, but yes, 5 like this. And then k, we then take k, yeah, plus k, and it's this times this, minus this times this, so it's going to be 4, yes, 4. So basically this vector is -2, -5, and 4. So nice and easy. We will say that the area is going to be the square root of the magnitude of this vector. So it's square root of -2 squared plus -5 squared plus 4 squared. That's it. So that's the magnitude. And if you do this, you will get 3 square root of 5. If you put this in your calculator, you will get 3 square root of 5. Is that okay? Yeah? Easy, yes? Okay, great. So that is the area of the parallelogram formed by the vector A and the vector B. So you find the cross product, and then you find the magnitude of the vector, which is the cross product. So that is A. B, part B, yeah, part B is now you have the three vectors A, B, and C. So you have three vectors. Now you want to find the volume of the solid formed by A, B, and C. So this time we want to find this volume, the volume of this three-dimensional solid. Now, do you remember how we did this? Yeah, You can, exactly, you need to use the matrix. It's going to be the absolute value of the determinant, yeah, of A, B, and C. So it's going to be the absolute value of the vectors, okay, A, 1, 2, 3. So you take the matrix of the three vectors, 1, 2, 3, and then minus 1, 2, 2, and 3, 4, 1. But don't forget to take the absolute value of this determinant. Okay, so first you need now to find the determinant. 1, 2, 3, minus 1, 2, 2, 3, 4, 1. So I need to find this determinant. So it's going to be 1 times, yeah, it's 1 times this times this minus this times this. So it's going to be minus 6. Yes, minus 6. And then minus 2 times, okay, remember it's plus, minus, plus, etc. So minus 2 times this, which will give us minus 1, and this times this, which will give us 6. I think then it will be minus 7, so? Or no? Yes? Okay. And then finally, plus the 3, yeah, the 3 times this times this, minus 4, and minus 6. So it's minus 10, yes, minus 10. So this is going to give us minus 22, so yeah, minus 22. Is this the volume? Is the volume minus 22? No. What is it? Absolute value of minus 22, which will be 22 like this. That's it. So again, really simple. There is absolutely no difficulty at all in these calculations. You can find them. It's really very simple. If you know the rules, everything becomes simple. Okay. Are we okay with this? Any questions, anything which is not clear here? Okay. So that is this question number 1 in the final exam. Very simple question on vectors. Now, question number 2 is on lines in 3 dimensions. We have a line L1 given by its parametric equations, and a line L2 also given by its parametric equation. First question is, find the point of intersection of these lines. So I need to find the intersection of these two lines. Okay. Now, I don't know how much you remember of this, but let's do it. Yep. So exactly. So you need to put x equal x. Yeah, the two x's are the same. If there is an intersection point, then that means the minus 1 minus 2t must be equal to minus 2 plus 3s, like this, x equal x, and you can also use y equal y, yeah? So 3 plus t equal to 1 plus s. So you need to look at these two simultaneous equations and find t and s, and then we need to substitute into the lines and see what happens. All right, so let's solve these two equations. Okay. Yeah, I can multiply, yeah, multiply the second equation by 2. Why not? Yeah, we can do that. Multiply it by 2 and then add, yes, that will be fine. Thanks, Saliha. Yeah. So we have this minus 2 plus 3s and multiply by 2. So it will be 6 plus 2t and 2 plus 2s. Good. And then we add. We can add to eliminate the t. So that will give us 5 on this side. And then minus 2 plus 2 will cancel. This and this also will cancel. And what are we getting on the right side? 5s, yes? 5s, which means s is equal to 1. Good. And then I will perhaps go and substitute in, yeah, we substitute in equation number 2, maybe, yeah? If we call this 1 and this 2, we will substitute in 2. So we will get 3 plus t equal to 1 plus 1. So t, yeah, is equal to minus 1. All right. So now, what do I do with these two values? Yeah, we substitute in the equations of the line. Yeah. So substitute. Okay, let me, yeah. So substitute in the line L1. In line L1, I'm going to get x equal. Remember, in the line L1, it's minus 1 minus 2 times t, which is minus 1. So it's 1. Y will be 3 plus t. So is 2. And the z is 6 plus 3, 6 plus 3t. So it's 3. So I'm getting the point 1, 2, 3. And then we substitute in L2. X will be minus 2 plus 3s, which is 1. So I get 1. Y is 1 plus s, which is 1. So I'm getting 2. And z is 1 plus 2s, which is 1. So I'm getting exactly also the point 1, 2, 3. So what is this telling us? What is this telling us? That the lines are intersecting at which point? What is the point of intersection of these lines? Yep. There is an intersection at the point 1, 2, 3. Yes. 1, 2, 3 is the intersection point. Great. Okay, and this point we get it by putting t equal -1 in the first equation, and by putting s equal 1 in the second equation, we are getting exactly the same point. So that means this point belongs to L1 and it also belongs to L2, and therefore it is in the intersection of the two lines. That's basically the way you do that. Okay. Now, when can you say there is no intersection? Sometimes there is no intersection. How can you see it that there is no intersection between the two lines? What happens if there is no intersection? How will you know? Okay. How will you know by these calculations? How will you know that there is no intersection point? Yes, the values of z, because we solved the equations using x and y, these two values actually will be the same. But the z may be different. So if the z's are different, that means these two lines, they cannot intersect. They don't intersect each other. That's basically what it means. Yeah. But if z is the same, like here, 3, 3, yeah, yes, exactly. Okay. Yeah, non-parallel, non-intersecting. Yes. Okay. Now, is there any? Yeah, there is a second part. So that's the intersection. No problem. Now I want to find the equation of the plane containing L1 and L2. So that's the second part of this question. So part B. Now you have your two lines, yeah, L1 and L2. There is a plane which contains these two lines, yeah. There's a plane. I want to find its equation. What is the equation of this plane? They intersect at the point 1, 2, 3. So this is the intersection. Now, do you remember how we did this? Any ideas? Okay, yes, A1 x minus x1 plus A2 y minus y1 plus A3 z minus z1 equal to 0. Okay, that's the general equation of a plane. Yeah, x minus x1 plus b or A2 perhaps, yes. Yeah, we can use A1, okay. But what is A1, A2, and A3? First, what is X1, Y1, and Z1? What is, hmm, no, yes. Yeah, X1, this is the point. This is one point on the plane. Yeah, so X1, Y1, Z1 is a point, any point on the plane, which we already have, yeah? Which is the point 1, 2, 3. So X1 is 1, Y1 is 2, Z1 is 3. خلاص, we know this. Yes. So we know this X1, Y1, and Z1. But what is missing now? What is missing in this equation? Yes, A1, A2, and A3 is a normal vector. A1, A2, A3 is a normal vector to the plane. So I need to find the normal vector to this plane. How do I get it? Uh, Parametric. Okay. No, no, not the magnitude. No. Okay. Good try. Yeah, I like to see your opinions and your ideas. I know it's a long time since you did this, but it's good to try. But so far, I haven't seen the correct answer there. Anyone else has any idea? Okay, the determinant of what? Okay, you cannot find the determinant of a point. Yeah. You need something else. Any ideas? Okay. Uh, Not necessarily a unit vector, any vector normal. A is a vector which is normal to the plane. It doesn't have to be a unit, and it could be anything. Okay, let me remind you. Uh, no, we don't need the unit vector, nor. We just need the normal vector. Now, to find the normal vector, what you need to do is like this. Let me remind you. We have the equation of the line, yes? The line L1. What is the vector direction of the line L1? Let me call this vector B, say. So the line L1 is in which direction? What is its vector? If you look at its equation, this equation has two things. It has a point on the line, and it has a vector direction. So yes, the line L1 is in the direction of the vector 2, 1, 3. Yeah, -2, yeah, -2, 1, 3. So the vector B here is -2, 1, and 3. And the line L2 is in the direction of which vector? If I call it A, not A, I can't call it A. It has to be like C, maybe, yeah? Let's call it C. What is the vector direction for the line L2? Can you see? For the line L2, it's in which direction? 3, 1, 2. Yes, 3, 1, 2. So get these two vectors. Now, if you have a vector B here, yes, now you do the cross product without the magnitude. No, we don't need the magnitude. So the vector A will just be the cross product of B and C. Yeah, so a vector normal yeah, vector normal to the plane is the vector we called A, which will be the cross product of B and C, like that. Or CB. Let me put it CB because the way I drew the graph, so it's C cross product with B. So that's what you do. So get the two vectors from the lines and get their cross product. That's it. That way you will get the normal vector. So you put here -2, 1, 3, and 3. Well, it's okay. Sorry, I think I need to start with C. Doesn't matter, by the way, it's okay, but yeah. It's very easy. Let me, sorry, is it 3, 3, 1, 2, huh? 3, 1, 2, yes, 3, 1, 2, not 3, 2, 1. Thank you, yes, 3. Three, 1, 2. Yeah, let me just remind you something here. So when you have two vectors, let's say you call them A and you call them this one B. If you take the cross product of A and B, what you will get is a normal vector. Yeah, it's a vector C. Yeah, the cross product of A and B will be normal to both of these vectors. It will make an angle of 90 degrees with B and also an angle of 90 degrees with A. So I think we did this many times. If you want a normal vector to two vectors, you take their cross product. So this vector is normal to A and B, like this. And so that's what we are doing here. So from this line, you get the vector 2, this is minus 2, 1, 3. And from this one, you get the vector 3, 1, 2. 3, 1, 2. This is the direction of the line L2. This vector -2, 1, 3. This is the vector direction of the line L1. Then you use these two vectors, you take their cross product. That's it. You take their cross product. So 3, 1, 2, -2, 1, 3. And what you will get is a vector which is normal to the two lines, and then we will use it to write the equation. So let's find this vector now. So what will it be? 3, so it's going to be 1, yeah, 1. And then 9 minus 11, I think, yes? Not, sorry, not minus 11, minus 13, huh? 13. Yes, so 3 times 3 is 9, and then plus 4 is 13. Yeah, so minus 13. And K is 5, like this. That's it. So now we can write the equation of the plane. So the equation of the plane is, so what will be the equation of the plane then, girls? What will it be? 1 times x minus, remember the point was, yeah, the point was 1, 2, 3, huh? Sorry, is it 1, 2, 3? Or what is the point? Yeah, the point was 1, 2, 3. So it's going to be 1 times, yeah, like this. And then what else? Not 2, y2. Look at the vector. 13, yes? Minus 13 times y minus 2, yeah? And then plus 5 times z minus 3 equal to 0, and that is the equation. But in general, you need to simplify this to make it into a simple equation. So minus 13y plus 26 plus 5z minus 15 equal to 0. So it's going to be x minus 13y plus 5z. And then maybe the numbers, we can take them to the other side. This, and this. I think it's 10, so it becomes minus 10. And that is the answer to this question. And if you take 1, 2, 3, it should satisfy this equation. 1, 2, 3, 1 minus 26 plus 15, it's going to be minus 10. Yeah, that's okay. So this is the equation of the plane. That's a very good question. Actually, I think last semester, when a question like this was proposed for the final exam, I basically realized there was no intersection point. So you cannot ask a question like this if there is no intersection point. If there is no intersection point, that means the two lines are basically not on the same plane. They are not on the same plane. So you can't really, there is no plane which will contain both these lines. Or if they are parallel, that means there will be an infinite number of planes. So a question like this cannot come without an intersection point. Good question, Nada. So the answer to your question is no. If there is no intersection point, there is no equation of the plane. Is that, did I answer your question? But good question there. Good question, yes. Okay, so that's the way you do that. First you find the intersection point, then you get the vectors from the lines. Yeah, you get the vectors. Then you get the cross product of the two vectors. You get the normal vector A, and then you just use the rule, and it's very easy after that. Just simplify, and you will get what you want. Can we move on from here? Are you okay with this? Again, I'm pretty sure you will get something like this. So make sure you know how to do it. All right, good. So that's fine. Okay, another classical question in calculus 2, finding the directional derivative of a function in a certain direction at a certain point. So you want, so basically here, what we are looking for is the directional derivative of the function f in the direction of a vector u, yeah, at the point 1, 1, 2, where u is in the direction from the point P, which is 1, 1, 2, to the point A, which is 3, 2, 0. So that's what we want to find here. Okay, so solution. Now, do you remember how we did this? Of course, we did something like this many times. Yeah. Yes. So we need first to find the direction. Yeah. So V, the vector V, will be find the vector. Yes. 3 minus 1 is 2. 2 minus 1 is 1. And 0 minus 2 is minus 2. So first, you get the vector direction. After this, what do we do, girls? Do you remember? The unit vector. Good. After that, we find the unit vector, u. Yeah? So what is the unit vector? Well, first you need to find the magnitude. Yeah? Okay, let me write maybe no need for this. Yeah. So it's going to be 1 over the magnitude of V multiplied by V. Now, what is the magnitude of V? Square root of 9, which is 3. So, yeah. Okay. So it's 1 over 3 times V, 2, 1, minus 2. So it's 2 over 3, 1 over 3, minus 2 over 3. So that is the unit vector. Okay. And then what else do we need? Do you remember? The point, of course, the point we need it's here, 1, 1, 2. Yeah. Okay, let me give you the rule. Let me just remind you of the rule. Directional derivative is generally speaking df over dx multiplied by u1 plus df over dy multiplied by u2 plus df over dz multiplied by u3. So what we need now is really these partial derivatives. Yeah. So I need df over dx if we look at the function f and its derivative with respect to x is y squared z. Yeah, it's y squared z. Yes, y squared z. So you want to find this at the point what is the point? 1, 1, 2. Yeah, 1, 1, 2. So substitute. So you will get 1 squared times 2. So this number is 2. Yeah. Okay. So there are 6 things. There are 6 numbers you need. 1, 2, 3, 4, 5, 6. Already we have u1, u2, and u3. So you need to find df over dx. Now the second one, df over dy. What is df over dy? It's going to be 2xyz plus z. That means at the point 1, 1, 2, we substitute. So it's going to be 4 plus 6. And df over dz is x y squared plus y. Yeah. And so its value at the point 1, 1, 2 is we substitute. Yeah, we substitute there. So it's going to be 2. Yes, it's going to be 2. Okay, great. So we have our 6 numbers. So now we can say, so the directional derivative of the function f in the direction of u at the point 1, 1, 2 is going to be 2 times what? 2 times 2 over 3. Yeah, good. 2 times 2 over 3 plus 6 times what? 6 times 1 over 3. Yeah, which is the u2. And plus 2 times u3, which is minus 2 over 3, like this. And that's it. After that, it's a matter of just multiplying. So 6, this is 4 over 3 plus 6 over 3, 10 minus 4 is 6 over 3. So the final answer is 2. So the directional derivative is equal to 2. Are we okay with this? Yeah. So first step, you need to find the unit vector that will give you u1, u2, and u3. And the second step, in a way, is to find the partial derivatives, df over dx, df over dy, df over dz, and you find them at the point 1, 1, 1, yeah, 1, 1, 2. So you get another 3 numbers, and then you multiply 2 times u1, 6 times u2, and then 2 times u3, and that will give you the directional derivative of this function. Okay, great. All right, let's do one more, and then perhaps we can, yeah. All right, I think we can do a couple more, yes. All right, this one, again, a classical question, 100% you will see this in your final exam. Find the critical points of this function, and basically, are they local maximum, local minimum, or maybe just a saddle point. Okay, so how do we find the critical points, girls? Do you remember? Yeah, fx and fy should both be equal to 0. Good. So first you find the fx, which will be 4y minus 4x, huh? Like this. And this should be equal to 0. And then fy, the partial derivative with respect to y, will be 4x minus 3y squared, also equal to 0. So we need to solve these two equations, find x and y, which satisfy these two equations. How do you think we can do that? Yes, from the first equation, you can see that 4y will be 4x. That means y is equal to x. And then I substitute this in the second equation, like that. One way of doing it. There is other ways also. You could add the two equations together to cancel the x's. That's also possible. So now that means it becomes 4x minus 3x squared equal to 0. This is a quadratic equation. It has two solutions. You can use your calculator, mod 53, or I can put x as a common factor, which will give us two solutions. X equals 0 and x equal 4 over 3. Now, because y is equal to x, that means y is also equal to 0. So we get the point 0, 0. And that means y is also 4 over 3. So we're getting the point 4 over 3, 4 over 3. So how many critical points does this function have? Two critical points, yeah? So we have two critical points. Two critical points, which are 0, 0 and 4 over 3, 4 over 3. Great. Now, to classify them, so that's the first part of the question. Now we need to classify them. How do we classify them? Yeah, we need to find fxx, fyy, and fxy, like this. Now, yeah, and then the d. Yes, exactly. So let's have a look at what is fxx. It's minus 4, yeah? Minus 4, yeah. fyy, so it's the derivative of minus 6y, thank you, yeah. Great, thank you. And fxy is 4, yeah? 4. Okay, great. Okay. That means d fxx fyy minus fxy squared will be 4 times minus 6y minus 4 squared. So it's going to be minus 24y minus 16. Okay? Now we can make the table. So we put the critical point here, critical point. The two critical points are 0, 0, and 4 over 3, 4 over 3. Then we put here fxx, fyy, yeah, fxy, the d here, yeah, and then the conclusion. Yes, we can put the conclusion here. So now let's have a look. Fxx is minus 4, fyy is 0 at the point 0, 0, fxy is 4. So this is going to be yeah. Let me just check this. What is going on? Yeah, so this is, the D will be minus 16. Okay. Which is negative. So it's a negative value. So what is the conclusion here? Because D is negative, what does it mean? It's a saddle point. Yes, saddle. Because D is negative, less than 0. Now, at 4 over 3, then this is still minus 4. Fyy is, what will it be if we multiply? That will be, what, minus 8? Yeah, I think fyy. Yeah. Fxy is 4. And then the D, what will be the D? 16, yes? I think, sorry, minus 48, yes. Fxx, fx, wait, fyy. Yes, I think it's 16, so yes, it's 16. Okay. But there is a slight problem there. I'm not sure why. Okay. Yeah, that's fine. 16. Yeah. Y is 4 over 3. Okay. So fx, what's going on here, guys? There's some. Is there a problem somewhere? Or let me just check. Fxx. Yeah. All right. Yeah. Yeah, that's what I'm saying. There is some problem here. Yes, yeah, it's not going to give us 16 there. Why is that happening? Fxx minus fxy squared, xy. Oh, sorry, this is minus 4. Sorry, yes, this is minus 4. So, yeah, this is plus 24. Yes, plus 24 here. Yes, okay, no problem. Yeah, it's 24y minus 16. Okay, yeah, which is 24. Yeah, so this is going to be plus, yeah, d is plus, and fxx is minus, yeah. So that means we have a local maximum at the point, yeah, because d is a positive number and fxx is negative, so that means we have a local maximum. Okay, I think we will, yeah, stop here. I think, or possibly, yeah. All right. No, I think I will take another 5 minutes from to complete this, and then after that, it's all about integration. So I want to finish this. After this, then it's the integrals, which we will do next time. Okay. Are we okay with these critical points? Is that okay, the way we did it? Any questions here? So fxx equals 0, fyy equals 0. You solve these two equations together. We are getting two critical points. Then we need to analyze them through the d, yeah, through the d here, and the fxx. You make this small table, and you will be fine. Okay, finally, then I want to do this one where we are given the acceleration of a particle, and I want to find the position vector r of this particle or this object. So I need to go up from the acceleration. I need to find what's the first step. We integrate. What will we get if we integrate? The velocity, yes, thank you. So we're going to get the velocity by integrating. What is the integral of cosine t? Sine t, plus a constant. Don't forget the constants. The integral of 0. The integral of this 0 is a constant. Let me call it c2. And the integral of 60, which will be 3t squared plus c3. Great, good. Now we know I'm going to use this now. The velocity at 0, substitute t equals 0 in the equation. We get c1, c2, and c3. And we are told that this velocity is 2, 1, 0. That means c1 is 2, c2 is 1, and c3 is 0. So that means now I can write the velocity as sine t plus what? Plus 2. Thank you. Yeah. And then c2, yeah, which is 1. And then 3t squared plus c3, which is nothing. So I will not put anything. Yeah. Okay. Nothing. Right. So let's close this. Right. So that's the first step. We found the velocity. Now, what is the second step now? We integrate again to find the position vector r, which is what we want. Again, it's going to be the integral of sine, which is minus cosine plus the integral of 2, which is 2t plus a constant, and then the integral of 1, t plus another constant, and finally 3t squared, which is t cubed plus a third constant, like this. Now we need to find C1, C2, and C3 by using this condition now. R at 0. First I put t equals 0 in this equation. I will get minus 1 plus C1, then C2 here, and C3. And according to the information we have, this is 1, 2, 3. Which means, again, that C1 is 2. Yeah, it's equal to 2. Okay, you put minus 1 plus C1 equal to 1. So C1 equal to 2. And then C2 is just also 2. And C3 is 3. And therefore, finally, so the vector position R of t is minus cosine t plus 2t plus 2, and then t plus 2, and t to the power of 3 plus 3, and that is the final answer. Are we okay with this? Is that clear? Easy? You can see really that this Calculus 2 course, girls, if you know the rules, if you remember the rules, and you know a little bit about Calculus 1, is really not that difficult. It's not a difficult course, believe me. Compared to other courses, this Calculus 2 is not such a complicated course. But you need to know the rules, and you, of course, also need to know how to integrate, differentiate. All of these things that you did in Calculus 1 are extremely important. That's it. Thank you very much for your attention. Any questions, anything you want to ask me today? No questions? Okay. Right. So I posted many exams. There is a folder called Review Final Exams in Blackboard. Go there, whenever you can. Open those files, try them, and hopefully things will be okay. Okay, so have a nice day and nice weekend and all that. So take care.